Hey guys, so we're going to talk today about the laws of logarithms, or the properties that deal with logarithms. Now remember, log functions are very similar to exponentials. In fact, that logs are the inverse of exponentials. So their rules and their properties relate to each other. So the first one, number one, says log base b of mn equals log base b of m plus log base b of n. So our exponent rules that kind of correspond to this log function. So say I had x to the fifth times x to the second. And I would know, what does this equal? Well, when we're multiplying two variables that have the same base, we add their exponents. So this would be x to the 7, which is, I'm actually going to write it out, 5 plus 2, which is x to the 7th. So this kind of relates to the logs, is that when we are adding two logs together, we multiply the terms to combine them. So if we're multiplying these terms, we add the exponents, the opposite here. So if we're adding the logs, we can combine them with multiplication. And this is going to relate to number 2. So say for my exponents, if I had x to the 5th divided by x squared. Well, when we divide variables that have the same exponent, or when we divide variables, we subtract their exponents. So this would be x to the 5 minus 2, or x to the 3rd. So similarly here, when we are subtracting logs, we can combine them with division. And then number 3, here, what it's saying is that if we're raising our term to a power, that we can bring it down in front and multiply. Now, how does this relate when we raise a power to a power? So for example, if I had x to the 5th squared, well, when we raise an exponent to a power, this becomes x to the 5 times 2, which is x to the 10th. So you can see how in exponents, multiplication and adding correlate. Same thing with logs. When we're adding, it correlates to multiplication. When we're subtracting subtracting the bases, that means because we were dividing. If we're subtracting, it goes with dividing. So first we're going to practice expanding the conditions, or expanding the logarithms. So I have to kind of look, okay, I've got log base 2 of 5ab. What is this operations between the 5ab? Well, this is saying 5 times a times b. So we're using our multiplying to expand it. So what we can do is every term that we're multiplying by, we can give it its own log and add them. So I could rewrite this as log base 2 of 5 plus log base 2 of a plus log base 2 of b. And now my log is fully expanded. So this would be my answer. All right, so now let's look at number 2. Log base 5 of 8 over x. Well, 8 divided by x means we're going to be using our divided by law. So here, if we're taking the log of two terms where we divided, we can expand them with a subtraction sign. So we can give them both their own log and put a subtraction sign in between them. Notice that the positive one is the one on top. The one we're subtracting is the one on the denominator. So we could rewrite this as log base 5 of 8 minus log base 5 of x. And this would be our answer. Again, there's not really any math. We're just kind of rewriting these. Number 3. Log base 2 of 6x squared y cubed. So the first thing, I'm noticing similarly in number 1, I am multiplying 6 times x squared times y cubed. So I'm going to separate those using our rule number 1, that when we're multiplying two terms together within a log, we can separate them or expand them with addition. So I could rewrite this as log base 2 of 6 plus log base 2 of x squared plus log base 2 of y cubed. Now, when I look at number 3, I'm not finished. And the reason is because notice that we have these exponents here on my x and my y. So what I can do is use my third law, is that anytime we have an exponent, we can bring this exponent down in front of our number and turn it into a multiplication. So this could be log base 2 of 6 plus 2 log base 2 of x plus 3 log base 2 of y. And this would be my answer. All right, so now number 4, we're kind of going to put it all together. So first thing I always want to do is separate my addition and subtraction. So terms on the top, I'm multiplying, so I'm going to break them apart with addition. Terms on the bottom, I'm dividing, so I'm going to break them up with subtraction. I'm going to leave the exponents first and then do that step next. So this could be log base 3 of 4 plus log base 3 of a squared minus log base 3 of b minus log base 3 of c squared. So the ones that were on the denominator, I'm subtracting, and ones that are in the numerator, I'm adding. My last step is I'm going to look at my exponents and bring my exponents down in front. So this should give me log base 3 of 4 plus 2 log base 3 of a minus log base 3 of b minus 2 log base 3 of c. Right, so number 5, log base 9 of x to the 4th divided by 729. Log base 9 of x to the 4th divided by 729. So what I want you to do is pause the video and try this one on your own. All right, check your answers. You should end up with 4 log base 9 of x minus the log base 9 of 729 as your answer. Now, technically, log base 9 of 729 equals 3. So technically, this would be a minus 3, but we're really just focusing on expanding and condensing them. So for the purposes of this notes and this assignment, this is how we would write this. Now, notice we do have this kind of note here off to the side. We did cover this in a previous note section, is that if I have no log base written, this is the same thing as log base 10. And then if I have the natural log written, this is the same thing as log base e of x. Now these two are special, not only because they occur in nature, but they are also ones that we can stick in our calculator. Our calculator has just plain log and natural log. All right, so now we're going to do the opposite, is we're going to condense these into a single log. So as I look at number 6, first thing I always want to do is look for numbers in front that go up as exponents. So first, I'm going to bring this 3 that's being multiplied up as an exponent on the x. So this would go to log base 5 of 7 plus log base 5 of x cubed. Then I'm going to focus on the adding and subtracting. So adding means we are going to multiply. And what are we particularly going to multiply? The x, or the 7 and the x cubed. So this would turn into log base 5 of 7x cubed. You don't technically need the parentheses, but it does help us determine what we're taking the log of. All right, number 7, I don't have any exponents here. So what I can do is go straight into the fact that I'm subtracting these two logs, which means division. And what am I dividing? I'm dividing the x and the 3. The x is positive, we're subtracting the 3, so the 3 term goes on the denominator. So this would be log base 2 of x over 3. Remember, we're just dividing the x by 3, not the whole log. So that's why we like to put it in parentheses. All right, 8. I've got this 1/2 here. So the 1/2, I look for numbers in front that can go up as exponents. So I'm going to bring that 1/2 as an exponent up on the m, and the 3 as an exponent up on the n. So this would be log base 6 of m to the 1/2 minus log base 6 of n cubed. Well, then I look at the fact that I'm subtracting these two logs, which makes division. So I'm going to divide m to the 1/2 divided by n cubed. So this would be log base 6 of m to the 1/2 divided by n cubed. All right, so what I'd like you to do is pause this video and try numbers 9 and 10. So first try number 9, and then if you want to unpause it and check your answer, and then we'll do number 10 as well. All right, so number 9. First thing I did is I did the parentheses first, so I combined this subtraction. Subtraction means division. And then I brought the 3 up as an exponent. So there's two different answers that you could do. Either one's fine. You could have the 3 on the outside of the parenthesis, or if you distributed the 3 first, you would have gotten a cubed divided by b cubed. Either one is fine. Both of them will be accepted. All right, so go ahead and pause the video. Try number 10. Pause the video and try number 10. All right, so we should get, as our final answer, log base 3 of 4m cubed over n squared. First thing I did is I took numbers in front and moved them up as exponents. And then remember, adding means we multiply, subtracting means we're dividing. So I'm multiplying 4 and m cubed, and I'm dividing by n squared. All right, our last one is utilizing the change of base formula. So what the change of base formula lets us do is it lets us figure out if our logs are not pretty numbers. So what we were doing before is we had something like log base 4 of 16, and we would set this equal to x. And then we'd write this as, 4 to the x equals 16, so x has to equal 2. Yay. Now, what happens if this didn't work out? Like 4 to some power. What happens if this was like log base 4 of 18? And we set it equal to x. And then we said 4 to the x equals 18. Well, who knows what x is? It's not going to be a pretty number. Okay, there's no pretty number that 4 to that power gives us 18. What the change of base lets us do is it gives us a way to rewrite these problems so we could stick them in our calculators. So if I have log base a of x, I could rewrite this as log base b of x divided by log base b of a. And our b can be any number that we want. The easiest thing for us to do is let b either equal 10 or let b equal e. And the reason is because these are in our calculators. So that way we could stick these values in our calculators. These would then become log of x divided by log of a. Or if we did base b, the natural log of x divided by the natural log of a. So what we're going to do is rewrite these. You should use a calculator for a lot of these. Some of them you don't necessarily need, but others you will. So if you don't have a calculator, go get one to help you figure these out. So as I look at 11, log base 81 of 27. So what I could do, if I'm using the change of base formula, I could make this the log of 27 divided by the log of 81. The base number goes on bottom, is kind of how we kind of figure it. Base on bottom, B and B. And then we'd stick these in our calculator. So it depends on the type of calculator that you're using. If you are using the ones that you used for Algebra 1 and Geometry, your keystroke would be 27 log divided by 81 log and then equals. And then if you did this correctly, your answer should come out to 0.75. 0.75. And we'd like to write this, if we can, as a fraction. So this would be 3/4. Now your calculator should be able to put this into fractions as well. There should be a kind of like an D arrow that would be able to put it in a fraction for you. So always try to put it in a fraction and see if it'll work. So number 12, log base 5 of 36. So this would be using the change of base, log of 36 divided by log of 5. So we would stick this in our calculator. And if we did this right, we should get 2.227 if we round to 3 decimal points. And this one does not go into a fraction, so our answer would just be 2.227. So what I'd like you to do is pause the video, try 13, and you're also going to try 14. So go ahead and pause the video. I'll work through 13 afterwards. I'll show you the answer, and then I'll pause it again to show you 14. All right, so check your answer for 13. Log of 32 divided by log of 8 would give us 1.6 repeating. And if we put this into a fraction, it should give us 5/3. All right, and 14. Should give us 2.085. Do the log of 18 divided by the log of 4. And it does not go into a fraction if we try and do that. So we'll just leave it as 3 decimal points. So I want you to do is always make sure we're writing out what we're sticking in there. Because that way we could at least get partial credit for the proper setup of our answer. All right, and that should be it for the notes.